Welcome to this portable oxygen cylinder identification presentation. This presentation is to make the viewer familiar with the identification process of a common portable oxygen cylinder assembly, or PCA, for the purpose of ordering, replacing, or even scheduling its maintenance. We will review the part number protocol and popular Avox and Scott model, locate the data plate with part number and serial number information, identify the outlet type, and identify various reservoirs, models for their testing requirements, and finally, review the regulator overhaul requirements that can be also governed by your local authorities. There are a variety of portable cylinder assemblies out there between B Aerospace and Avox, but today we'll focus on the 5500 and 9700 series Avox models. The part number protocol for the 5500 and 9700 series PCA is similar. The first 4 digits define the actual series. Then, specific cylinder properties such as cylinder size, the regulator combination, its color, and the harness type. Then the flow rate for each outlet, keeping in mind that there's usually 2 different outlets, principally a 2-liter and 4-liter per minute outlets. You could also have both outlets to be at the same rating, such as 4 liters per minute. The altitude setting for a pressure flow relationship. In this example, we are showing a 23,000 feet cabin altitude setting. And finally, the outlet model. The part number and serial number of the assembly is located by the manufacturer on the regulator or on a label directly on the cylinder. Some operators are tracking the assemblies using the steel cylinder serial number or by their own internal identification protocol. When ordering or installing a replacement portable cylinder assembly, or PCA, be careful that the outlet model corresponds to the mating connector of the mask that you have in service, and vice versa evidently. The Avox Scott family PCAs have more than 12 different models of outlets. There has been unfortunate incidents where oxygen couldn't be administered to a passenger in need due to a wrong mask PCA combination. The outcome of this could be catastrophic. As mentioned previously, the outlet model on a given PCA is the last letter of the part number. In this picture, the A suffix, so to speak, is a bayonet model, while the B is a plug-in style. Actual part numbers of outlets and corresponding connectors are listed in the PCA CMMs. There are 3 possible types of cylinders for the 5500 and 9700 series PCA, each having different life limits or hydrostatic testing requirements. The steel cylinders are manufactured according to specification DOT3AA or DOT3HT, and the carbon fiber reservoir are fabricated according to special permits. The steel cylinder specification is stamped on the shoulder of the cylinder, while specifications of the carbon fiber units are on a label. DOT3AA cylinders are widely used in a variety of industries, and they're not limited for aircraft. They're not manufactured by the application OEM such as Avox or Zodiac, but by specialized cylinder manufacturer. They do not have a life limit, providing they successfully pass their hydrostatic test and accompanying visual inspection. You may see a plus and a star stamp beside an hydrostatic mark. This is allowing for increased pressure or a 10-year hydrostatic interval under certain usage of the cylinder. Canadian operators should refer to publication CSA B339 for more details on this. Take note that these increases may not be recommended by the manufacturer of your PCA, such as Avox or BE. Hydrostatic testing is required every 5 years for most applications. The DOT3HT steel cylinder identification is stamped on the shoulder of the cylinder. Take note that they do have a life limit of 24 years or 4,380 pressurization cycle, whichever occurs first. Hydrostatic testing is required every 3 years. Refill activities should be tracked if they are occurring more than once every other day. Thinner wall on these make them more vulnerable to nicks and dents. Greater handling care is required. Carbon fiber cylinders have a calendar life limit of 15 years. Hydrostatic testing is usually every 5 years. You may find these specifications on a document called Special Permit. When mounted on a 3AA or carbon fiber cylinder, the regulator overall interval is 5 years. When mounted on a 3HT cylinder, this interval goes to 6 years to correspond with every other HST activities. Always check your most recent component maintenance manual for current intervals. This concludes our presentation. Take note that this presentation can be downloaded from our website at www.sprint-aviation.com, and you may use it for non-revenue training within your organization. Thank you very much again for listening.